Prep Stat students, Mr. Mitchell here. Today we're going to continue with confidence intervals. We're going to take a look at confidence intervals when you're dealing with a small sample size. So we're trying to estimate a mean for small samples. Okay, so let me launch the PowerPoint here. So we looked at confidence intervals before, and they were when we had a sample size of larger than 30 is typically the number that you use. If you have 30 or larger from your sample size, then you do a Z interval. You use the Z table, and we talked about that before, worked on that. So now if we're less than 30, then what do we do? All right, so we're not going to have a large sample. It's impractical to use a large sample. It's impossible. We just don't have the resources to collect a large data set. Maybe the sample can't be large because it's not a very big population to begin with. So for whatever reason, we don't have a very large sample. So then does that mean we just can't do a confidence interval? No, we can. We just have to change a couple things. So we need to do a T distribution. So here's the normal distribution. And then here's your T distribution. Notice they're both bell curve shape. If you notice, the normal distribution is taller in the middle. That means that there's less variability. It's tighter. Things are more compact in the center. The T distribution is lower in the center and has more stuff on the tails. That just means there's more variability. The spread. Okay, we talk about spread. There's more spread with the T distribution. Okay. So we got to talk about degrees of freedom, and the best way I can describe what a degree of freedom is, to find it, you do n-1. You just take the sample size and subtract 1. So if your sample size is 20, your degrees of freedom are 19. And the best way I can describe that is if I have a class full of 10 people and I have 10 candy bars to give to them. Well, wherever I start, the first person has 10 choices, and the next person has 9, 8, 7, 6. When I get to the last person, they don't have a choice. They have no freedom of choice, if you will. And so that's the best way I can describe what a degree of freedom is. Okay, so that's why it's n-1. You're basically subtracting off the last thing or the last person that's being selected. They don't have a choice of what their options are. They're just getting the last thing. So really, that's what the n-1 stands for. But that's the best way I can describe what a degree of freedom is. You don't really have to know what it is. You just need to know how to find it in order to use the table. Okay. So we've talked about confidence intervals before, and remember the point estimate's in the middle, the mean goes in the middle, and then you add and subtract the margin of error on both sides. To find the margin of error, you need to find a critical value. We called it Z star or Z sub C. To do a T distribution or a T interval, you have to find T star or T sub C. And it's not really any more complicated than finding Z star. It's maybe a little bit more work, but it's not really that complicated. There's a table in your textbook, and you go to where C is. C is the confidence level. So for this example, we're going to find a 95% confidence interval. So we go to the column that's 95%, 0.95. And then we have to find our degrees of freedom are over here. So if our sample size is 8, that means our degrees of freedom are 7, right? n-1, so 8 minus 1 is 7. And then we find where these two intersect. So my T sub C or my T star is 2.365, 2.365, okay? So that is the critical value there, okay? Just some arrows and then the answer. So to find a confidence interval, again, we talked about it. To find any confidence interval, it's the point estimate. In this case, it's a mean plus the margin of error and the mean minus the margin of error. That is how you find every confidence interval ever. It's just a matter of, well, maybe sometimes we're not doing a mean, maybe it's a standard deviation, maybe it's a proportion, maybe it's something else. But you always do margin of error plus the point estimate, margin of, and then the mean minus the margin of error. Okay, so we have to find our sample mean, which typically is given to us, and then we have to find our margin of error. So the margin of error is calculated with the critical value. Used to be, if it's a Z interval, it's Z sub C or Z star. If it's a T interval, which we're learning now, it's T sub C or T star. You can call it either way. And then you take your sample standard deviation, divide by the square root of n. All right, you do need to know the confidence level you're looking for, okay, to find T sub C or T star. So let's practice one. The mean weight of 8 fish caught in a local lake is 15.7 ounces with a standard deviation of 2.3. Construct a 90% confidence interval for the mean weight of the population of the fish in the lake. So a 90% confidence level. So I'm going to give you the answer, and then we're going to kind of go back. We're going to kind of go backwards from that. Okay. So here's the answer. Now we got to go calculate that. Okay. So we need our sample mean is 15.7. So let's record that. Sample mean is 15.7. I know my pen's being goofy. And then my standard deviation is 2.3. And it says 8 fish. So that means N is 8. And then my confidence interval level was 90%. Okay, so that's all the information that I need. Now I need to go to my table. So I'm going to and this table looks a little different on paper versus what I have online, and it's still the same thing. So it's, you go to a T distribution table or a T table. I think it's A10 in your textbook. And so we find the confidence level down here. Sometimes they're down at the bottom, sometimes they're at the top. It just depends. The one that we have in our textbook, it's at the top. This one's at the bottom. So I find my 90% confidence. And then my sample size was 8. So then I do 8 minus 1 is 7. So we're looking for this column and this row. So it's 1.895. 1.895. So my T star, 1.895. So again, to find this answer, we're going to take we're going to take 1 point, oh, no, that's not right at all, 1.895. And this is our margin of error. It's either M or E, either one. 1.895 times 2.3 over the square root of 8. So we got to type that in our calculator. So we get our calculator out, 1.895 times 2.3 divided by the square root of 8. So that equals 1.54. So that's our margin of error. That's how much you can miss. Again, the concept of margin of error, when you pull into a parking space, this is the parking space. Your car is smaller than the parking space. So you can pull a little bit further left or a little bit further right and still be in the parking space. So now we're just going to take our mean. Notice we haven't used the mean yet to calculate the margin of error. The mean has nothing to do with that. So now we're going to take the mean plus this number and then the mean minus this number. So 15.7 minus 1.54 is 14.16. Okay, so this plus or minus 1.54 is going to give me this number and then this number. Okay, and if you take 15.7 plus 1.54, you get that. So there's your confidence interval for this particular problem. Okay, that's how we calculate confidence intervals for a T distribution. And so this is the interpretation of a confidence interval. We are 90% sure that the true mean weight of fish in the lake is between these two numbers. So we're pretty sure, we're 90% sure that the mean weight of catching 8 fish would be between these two numbers. That's the way you interpret it. All right. So here's another question. The mean height of 15 third graders at Falling Spring Elementary School is 48 inches with a standard deviation of 4.6. construct a 90% confidence interval for the mean height of the third graders at Falling Spring Elementary School. All right. So here's our mean. So we need this number. And then we need this number. We're going to have to look up our T sub C, or our T star. And I know it's 15, so N is 15. So we have to do some calculations based on that. Okay. So let's go to our table. So 95% and a sample size of 15. So we go to our table. So 95% is this column. And then our sample size is 15. That means our degrees of freedom are 14. So that's 2.145 is our T sub C. Okay. So T sub C is 2.145. So now we can find our margin of error. 2.145 times our standard deviation of 4.6 over the square root of 15. And so if we calculate that with our calculator, got 2.145 times 4.6 divided by the square root of 15, you get our margin of error of 2.55. Okay. And so then you take the mean, which is 48. You add this number, you take 48 and subtract this number, and you get these. Okay. So there's your answer. And so then there's your interpretation. We are 95% sure that the true mean height of third graders at Falling Spring Elementary School is between that number. Okay, those two numbers. All right, let me know if you have any questions.